In this video, we shift to a new topic called binary relations. Before we define specifically what binary relations are, we're going to look at the notion of relationships between people and other objects. Then we're going to give the definition of relations. And then we're going to find examples of relations and elements in those relations. Alright, so we have a lot of words to describe relationships between pairs of people. People can be involved in relationships of family, relationships of friendship, and of love. And there are lots of reasons these relationships are important to the people involved. But from another point of view, there are some other important aspects of these relationships as well. From a descriptive point of view, they can be described as relationships between two people. Right? Two people can be in the same family. Two people can be friends. One person can love another person, which involves two people. And some pairs of people satisfy the relationship and some do not. You can have two random people, they may or may not be in the same family. Two people may or may not be friends. Given two people, one may or may not love the other. And the order of the people involved may or may not matter in these relationships. For instance, if you're talking family and friendship, they do not depend on the order. If two people are in the same family, whoever you list first in those two people doesn't affect whether it's true. However, love can depend on the order, depend on the people. So it's possible, for instance, that Jojo may love Joanne, but perhaps not the other way around. And so we need to be able to say that it's not just depends on the two people or two objects involved, it depends on the order as well. So since these relationships depend on pairs of people, and since the order may matter, then we are going to be able to describe these relationships with ordered pairs. So as an example, for the love relationship, if Jojo loves Joanne, then the ordered pair Jojo-Joanne could be thought of as part of the relationship, where the first person in the ordered pair loves the second one. However, if Joanne does not love Jojo, then Joanne-Jojo would not be part of the relationship. So it follows that any mathematically precise definition of what we're going to call relations, they must be as a set of ordered pairs. Alright, so now we are ready for the definition of relations, which may not seem much when we say it, but if you look at it in the context of what we were talking about in the previous slides, has a little bit more meaning. So if let A and B be two sets, a relation from the set A to the set B is some set R of ordered pairs, right? We're talking about ordered pairs, where the x coordinates of the ordered pairs are elements of A and the y coordinates are elements of B. And another way of saying that is the relation R is merely any subset of A cross B. Right? So you have a Cartesian product of sets. A relation is any subset of that Cartesian product of sets. So a few remarks. First of all, A and B do not have to be sets of people, but they can. Right? So relations can describe relationships between any kinds of objects. If the ordered pair A, B is in R, that is the same as saying that A is related to B in that relation. And if AB is an R, we can sometimes say that same thing with the shorthand ARB. So ARB is a statement that says A is related to B under the relation R. And finally, if AB is not in the relation R, that means A and B are not related. Right? AB in R means they are related. AB not in R means they're not related. So R is a very precise way of defining the rule of when two objects are related and in which order. So we've talked a little bit about people and some of the relationships that can be described by ordered pairs of people. Now let's talk about some other things that are a little bit more relevant to math, say relations between real numbers. So we're going to define the relation R on the set R. That means from R to R, the set of real numbers. In this one, ARB is going to be true. Remember, it's a true statement. A is related to B when A is less than or equal to B. So we know that 2 is less than or equal to 5. That is true. So that means the ordered pair 2, 5 is part of the relation R. And another way of saying that is the statement 2R5 is true. However, 5-2 is not an R, so if I were trying to say the statement 5R2, still a statement, just not true, it's false. All right, let's look at sets. A natural relation to define on sets is, well, the set. We're going to call the relation S, and ASB is the statement A is related to B, means that A is a subset of B. Right, so it's a subset relation. So since the set of integers is a subset of the set of real numbers, that means ZR is an ordered pair in the set S, or in the relation S. And also it means that the statement ZSR is a true statement because Z is a subset of R. However, Zn is not an S because the integers are not completely contained within the natural numbers. So, I mean, relations can be literally between any types of objects, whether mathematical or not. They just have to relate pairs of objects. So you got to say this relationship exists between two objects, not more and not fewer. All right, so now that you have a handle on what relations are, go ahead and work on the activities for Introduction to Relations. And then there's another set of activities that also goes with this video. That PDF file is called More Relations.